Hi. We're going to go through the Purse project here. This is an important project that really kind of gets down into the heart of working with arrays and array lists, or array lists actually, only in this Purse class. So we've got a Purse tester that's been given to us, and so I guess I'm going to copy that and I'll set that up in my project. And then I'm going to open up this Purse project description, and we're going to go through and solve these one at a time. I'm recommending that you probably set this on 1.25 speed to go through a little bit more quickly, or scrub through to find the part that you're really interested in figuring out. Again, there's so many important things that are covered in this particular project, so it's really important that you have a good understanding of how it all works. Let's go ahead and get started, and we'll see how this goes. So I've created a new Purse project here, and I'm going to say there's a new class. This will be my Purse class that I'm going to put in there in just a moment. I'm also going to create this Purse tester class, and I'll just go ahead and open that up and paste in that tester that we were working with just a few moments ago, or that I was looking at just a few moments ago. And yeah, there's all that. So hopefully we'll be able to, geez, there's a lot of tests there. Hopefully we'll be able to get that going in just a few moments. You can see it's can't finding some of the methods in the Purse class because we haven't written them yet. So we'll come back and hopefully those will be all set by the time we run that tester. Let's open up Purse then. So this is a class. It's not a main program. It's a class. And so I'm not going to be writing any comments here for the most part, although those are always helpful. Yeah, we're going to buzz through pretty quickly here and just see if we can hit the highlights and get the code working. So what do they tell us here? The Purse class allows for, I'm going to draw quite a bit as well here. The Purse class allows for the management of a collection of coins. The names of the coins will be kept in an array list of string values. So we're going to set up something, maybe coins, maybe Purse. I guess we're calling it the Purse class, so maybe we'll call our array list coins. And we're going to have a constructor, which creates an empty Purse object, a mutator method, add coin, which adds a coin to the Purse, and then a toString method that prints out the contents of the Purse in this format with square brackets and commas and no spaces between those. So let's go ahead and do that, figure out how to do all those things. I guess we'll, let me switch over here. We're going to create, well, if we're doing an array list, we need to import java.util.arraylist. And in here, we'll set up that first array list of coins. Of course, they're really going to be string values describing those coins. So we'll call that coins. Remember, when we do these, we declare the array list first. We declare all the instance variables first. And then in the constructor, we initialize. So you declare and then initialize. So down here, coins is going to be equal to a new array list of coins or strings. Don't forget the parentheses there. And then we're all set. And that's the empty array list. That's our constructor. So we're all set to go there. I'm going to go ahead and get rid of this comment here. Yeah, we'll just go ahead and get rid of this and deal with the actual method. They said we were supposed to have this add coin string new coin. I'm just going to steal that if you don't mind. I'm going to copy that in there. And let's see, public. We're probably not going to be doing anything with this. We're not going to be returning a value, so we'll just be void add coin. We'll send in the new coin, and I need to take that coin, that string, and add it to my array list of other coins. So it's simply going to be coins.add the new coin. That'll put that in there. And then the last thing they wanted us to kind of warm up with here as we're taking a look at this is they wanted us to write this toString method. And there are quick and fancy ways to do this. I'm going to actually go through and do it the hard way just because it's nice to be able to practice going through arrays. So we're going to be returning a string value that can be used to print out the status of the Purse. And this is the toString method. I'm not sending anything in. I'm just going to get some return value here, some what are we going to call that string that we send back? The result. Sometimes I'll just use that as a generic value. And it starts out purse and then square brackets. And then we're going to add in all the string coin values in there. Sometimes we're going to be putting a comma in there too, but not in front of the very first one. So we covered this trick in class a little bit. I think what we'll do is we'll set up a little loop here for int I equals 0. We're going to go through all the coins. I less than the full length of that array list. And remember that array list coins, the full length is referred to with the size method. And we'll do I++, so we're going to hit every single coin in there. Now, if we're not looking at the first one, if I is greater than 0, if we've already covered the initial coin, then one of the things I'm going to do is I'm going to add to result a comma. So what that means is after the first one, every time we're going to print out a result or put a coin into the result, we'll also put in a comma. But we won't do that for item 0 for the very first one. So let's see, result plus equals coins get I. So after the very first one, we'll put a comma in, and the result, if it is the first one, we won't put the comma in, but we will add in that first result. Yeah, and by the time we get all the way done then, the only thing we need to add to result is that closing square bracket. We'll take a look at this in a moment. And then I'm going to return that result. We'll send that back and we'll see what happens. I think that's probably what I want. I'm not sure if my tester is set up to be able to handle all this because there are a bunch of other tests like reverse that we haven't written yet. So I could, I suppose, comment out all those other tests, but I think what I'm going to do here is I'll just I'll create a purse here and add a few things into it, and we'll see how it's working. All right, so we've compiled that. Let me create a new purse. There it is, purse 1. And let's add a couple things to it. I'll put a Bitcoin in there, and I'll add a quarter in there. Let's see, add coin. I'll put a quarter in there. And then let's see what happens when we call the toString method. When we call the toString method, you can see that we've got a purse with a Bitcoin and a quarter. I've got open square brackets and closed square brackets and that comma in there. So this is the correct format for the thing that we're going to be doing. Cool. Working great so far. Let's continue with purse and then see what else we can do with this. We've got the first one done. We've just got 4 more. All right. The reverse method is going to reverse the sequence of coins in the purse. If we're going in quarter dime, nickel, dime, then we should be reversing it so that it says dime, nickel, dime, quarter, dime, nickel, dime, quarter. And this is a pretty standard kind of thing to be able to do to reverse a list. It's nice if you can do this without having to create a new list. I think we talked about this a little bit. If I've got 4 items in my list here, one way to do it, if this is the original list RL1, we could, I suppose, create RL2, copy these into RL2 in reverse order. So we could go through and say, we'll do this here, then do this here, then do this here, then do this here. And then copy these items back into that first list. And that would work okay. We would be taking up some extra space to create this extra array list, and that's not a big deal for 4 values. As we mentioned, if you've got 1 million values, that may be a little bit more problematic. So it's probably a little bit nicer if we could just do this so-called in place, if we could reverse this in place. So if I've got these 4 items here, 0, 1, 2, 3, if I could somehow take this first item here, stash it away for a moment in a temporary variable, bring the 3rd item in there, and then drop this down, that would have exchanged those 2 values. And then I could go to the next value, and again, put it up into a temporary value, bring this guy up here, and then drop the temporary value down there. I just need to keep track of, I guess I'd have a temporary variable. I'd need to keep track of I equal to 0, then 1. I'd only go halfway through the list because if I continue going, then I'm just going to switch things back around to where they were before. So I only want to go halfway through the list. So I do need to keep track of I equals 0, I equal to 1, and then I need to somehow calculate this value at the end of the list, and then this second to the end of the list. I need to be able to manage all of those. And so how do we do that? We talked a little bit about how to do that. Let's write the reverse method, public void reverse. We're not going to be sending anything back. We're just going to be reversing all those items in place in the list. So let's go through that list. Let's start at the beginning. For int I equal to 0, we're only going to go up to coins.size divided by 2. Remember, we're only going halfway through the list. And we might be worried about whether or not what's going to happen if we have an odd number of items in the list. It turns out that this works out just fine for that strategy, for that concern. So that's not too bad. Let's see now. So I'm going to take that first item. I'm just going to write down some numbers again here and see what happens. If I've got 1, 2, 3, 4, 0, 1, 2, 3, I want to exchange the values in item 0 with 3. Those two are going to exchange. And then 1 here is going to be exchanged with the item at position 2, and so on. So if I've got I going from 0 to 1, how can I calculate 3 and then 2? You can notice that the size of this list is 4. Coins.size has a value, coins.size has a value of 4. So in this particular case, if I was 0, I would want to somehow be able to calculate 3. And that's equal to size minus 1. I can't really do size minus 1 every time, because if I'm trying to do 1 over here, size minus 1 is going to give me 3 again. But notice that this is 0, so we could do actually size minus 1 minus I. What would that do? That's going to give me 4 minus 1 minus 0, which gets me 3. Size minus 1 minus I, when I is 1, that'll be 4 minus 1 minus 1. That'll get me to 2. So this calculation should work for me determining what the index is for the corresponding value that I'm going to swap out there. So we'll see how that works here. We'll see if we can make that happen. So as I go through, I guess I'm going to, in a temporary variable, I'm going to store the item at the beginning of the list. So that'll be coins.getI. I'll get that first item. Then what I'm going to do is I'm going to say, into that coins.getI, now that I've saved a copy of what was there, I'm going to set at that I position a new value. And the value that I'm going to set at that position is the value that I get from coins.size minus 1 minus I. That was that calculation that we figured out. So again, we're going to set a new value at the beginning there, and that value is going to be the one that we calculate from the end of the list. And then the last thing we're going to do is we've replaced the item at position I, but what about what was here? We need to now take that item, that end of the list item, and we need to set the coin that was at that position to the value that was at getI, and we saved that in the position or in the variable temp. So that's going to swap those two out. So let's try that. Let's run that and see what happens. Looks like I forgot something there. There we go. There we go. So we'll go ahead and compile that, and we'll try and see if we can run a real quick test and see what happens here. So I'll create a new purse. I'll just put a couple of values in there, and I'm not going to do a super thorough test right now because we need to get through the rest of the assignment. And I've done this before, so I have some confidence that we're on the right track here. So I'm going to put a quarter in there with a Q and a P for a penny, and maybe I'll add one more. I'll put a dime in there, a D for the dime. So if I take a look at my purse, I've got quarter, penny, dime. I'm going to call reverse on it, and now I'll try and print it out again. And instead of quarter, penny, dime, now it's dime, penny, quarter. So it looked like that reverse operation worked there. Good, we're in good shape. Let's keep on going. These are the easy ones. We're going to get to the tough ones in a few moments. Add a method to the purse class transfer that transfers the contents of one purse to another. So if I've got my purse with this and your purse is that, after we transfer from your purse to my purse, I'll get those new values there, dime and nickel, added to the end of my purse. And your purse will be wiped out. This is a little bit unusual, interfering or interacting with another object's variables, especially when they're private. But if it's the same class, you can do that. You're allowed to do that. So let's figure out how to write this transfer method. Transfer from another purse. We're not going to be returning any values here, so this will be public void transfer. And we're getting this from another purse. And what are we going to do? I guess I need to go through the other purse and remove those items from the purse and put them into mine. So how do we get the coins in that other purse? I guess I'm going to set up a loop that will go through that other purse. For int I equals 0, I less than other dot coins dot size. This other says, let's get the other object. Dot coins refers to the coins in that, and then we'll just go on through. And every time I get one of those coins, I guess, well, first of all, I want to put it in my purse. So I'm going to go ahead and do that. I guess I'll take my coins. And if I'm worried about the other coins versus my coins, remember you can always say this dot coins to refer to your own instance variable. And I'm going to add in the item that I got in that other purse. I'm going to add in other.coins.get I. So that should put that into my purse. Now, how do I get it or remove it from their purse? Because we can't just create money, have money in their purse and my purse. It has to go from their purse to mine. So now we also need to remove it. Is there a remove or a delete or something that we can use for that? I don't know if you remember, we should take a look back and see how we can remove coins. I'm going to try and do this. Other.coins.remove I. We'll see if we can get rid of it that way. And nothing, again, I need to return. I'm just going to go through all the items in their purse, and then I'll see what happens in mine. Does that compile okay? Well, apparently it's working so far, so let's see. Let's make up a new purse here. And let's just tell you what, let's just keep it simple. I'm not going to have any items in my purse. We'll make up a new, another new purse. Here we'll call that other purse, just so we can keep those straight. And let me add a couple of coins in there. We'll see how this works. I'll add a penny, putting a quote around there, and I'll put in a nickel. And then let's call the transfer method on this other purse. So we're going to transfer from other purse, which is what I called it, to our purse. Now we got to check a couple things. First of all, did we get it in our purse? What's our toString? It looks like we only got the penny. Interesting, we didn't get the other one. And what happened over here, if I take a look and see what's in here, it's still got the nickel, so it didn't go all the way through that other purse and bring everything over. So what happened there? How come it didn't get all of that stuff? I have to take a look and see here. We're going through the size of the array in the other purse. I thought that was going to go all the way through. That would go 0 and 1, and that would get theirs and add it to ours. Oh, isn't that clever? Isn't that clever? So here's this is a little bit of a challenge. So this is what happens in array lists. Think about what's happening here. Oh, classic mistake. I'm so glad I made this. So the other purse looks like this. It's got a 0 and a 1 in it, right? And what, I forget what we put. We had a penny and a nickel, maybe. So take a look at what was happening to our list when we said I was equal to 0. We said, okay, yeah, get the coin that's at that position and copy it into ours. And it did that. And then the next thing I did is I said, well, remove that from the list. So it took this out of the list, which means this list now just consists of this single item, which is at position 0. So nickel moved down to the 0 position. If you want to think about it that way, nickel now has an index of 0. Meanwhile, what's my loop doing? My loop is going to go up to, well, it's going to check to see if we're less than the size of the list. Coins.size at this point is 1. I has become 1. We added 1 to I, so I has become 1. So we're checking to see if 1 is less than the size, and it's not anymore. We got rid of that thing, that item there. So we're not going to continue through the list anymore. That's a little bit of a challenge. I guess I don't want to remove these coins right away until I've transferred them all. Or maybe I want to find some other way of going through this list. There's a couple of different strategies that you can use for this. Here's another classic strategy that we'll take a look at here. One of the things you can do is you can move backwards through the list. If you're removing items backwards from the list, then what we can do is we can say, well, I'll bring this one in, and then I'll bring this one in, and then I'll bring this one in. So as the list gets smaller, we're going to be tracking down through there and still getting them. The problem here is, of course, that's going to reverse our list if we move backwards through the list. So that's not going to work either. So maybe we could do something clever with a while loop. With a while loop, what we could do is we could say, as long as we're going through, we'll just keep pulling items off that list. And we'll adjust as we go. So how about if we do this? Yeah, I think maybe this will be a better way to do this. Oops. What we'll do is we'll say, while there are more items in the list to pull off, in other words, while other.size, coins.size, is greater than 0, while we still have items to get, we're going to pull things off there. And we'll just get the item at position 0 every time. So we'll get whatever's at 0, we'll add it into ours, and then we'll remove it. And then we'll just keep on, we'll remove it from that position. It should be position 0. And then we'll go up and it has the size drop to 0. If it hasn't, then we'll get the next item at that first position and pop it into ours and then remove it. So a little bit of a clever hack to get around that. And we can double check that and make sure that's working with a couple more tests here. So again, I'm going to leave an empty purse for that first one there. Let's create a new purse called other purse, and we'll see if we've fixed that problem. Oh, that was a great little challenge there. We'll do a penny, and then we'll add a nickel in there, and we'll see if we get both of them this time. So over here, toString, we currently have nothing in there. And in the other purse, we currently have the penny and the nickel. So let's see if we can transfer everything from other purse. And then we'll see what we have now. toString has penny and nickel, so we pulled those off. And toString, we have nothing left. So we successfully pulled those coins out of that purse. Nice. Let's keep on going. We're in great shape here. Close these all out. Let's see what we can do next. Write a Boolean method for the purse class, same order, that checks whether the other purse has the same coins in the same order as this one. Well, that's kind of cool. I guess I'm pretty good at going through loops and figuring out when things match. I guess the first thing you kind of have to be careful of in this is, if this is my purse, bang, 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 and this is the other purse, and the other purse has all these other coins in it. I guess the first issue is if I start going through and checking to see if these are all the same, I'm going to run out of coins in my purse while there are still coins to check in the other purse. And so that's going to give me like a bounds error or something if I'm going through. So I think the first thing I'm going to do is I'm just going to check to see if the two purses have the same size. If they don't have the same size, then I know they don't have the same coins in the same order because they don't even have the same number of coins. So let me check that first of all. Let me in this, what's it called again? Same order purse other. Let's get that started. Public, I just typed so many random things. Avoid same order. There's going to be a purse other. And again, we're going to go through and first of all check to see if they have the same number of coins. So, or maybe if they don't. If my coins.size is not equal to other.size, well, that's pretty easy then. I'm just going to return false. Yeah? Return false. Oh, and this is supposed to be Boolean. You knew that, huh? It's supposed to be Boolean. I'm going to return a false value there. Else, if they are the same size, then I can start checking all these other things. Should I be really careful and put those curly braces there? I'll put those curly braces just for form's sake. So if they don't have the same sizes, I'm going to return false. Otherwise, I can start going through. I know they have the same number of coins, and now I'm just going to go through. And I guess what I'm going to do is I'll check every coin with the other coin, and if I ever find that they don't match, well, then those coins aren't in the same order, so I'll just send back false because they didn't match. So let's set up a loop to go all the way through. I am going to use an indexed loop so I can refer to the index of both array lists. So for int equals 0, I less than coins.size. It doesn't matter because we know at this point they have the same size. And I plus plus. And if the coin that I'm looking at in my loop, coins.getI, is not equal to the coin that they have in their coins, other.coins.getI. If those two don't match, then I'm going to return false there as well. Because these are supposed to be the same coins in the same order. 0 should match 0, 1 should match 1, 2 should match 2. And if they don't, I'm going to send back false because they're not correct. But if I go through every single coin in there and I never sent back false, then that means I went through the entire set of coins and never sent back false. That means everything passed, so I can return true for that. And oops, looks like I have an extra curly brace there. I think that's probably going to do it. That should be coins.size, huh? There we go. Yeah, I think that's probably going to work. We could try that in a few minutes. You know what? I'm going to, I'd like to run the tester. I'm really interested in running the tester now that I've got a lot of the code written here. But it's still not compiling because I haven't written same coins yet. So you know what I'm going to do is I'm going to write same coins here. Close that. I'm going to write the method same coins, but I'm not going to complete it. In other words, I'm just going to say public Boolean same coins purse other. So that's the signature. That's the correct signature. And I'm just going to return false every time. I know it's not working because it doesn't have any code in there, but this at least will compile. And now my tester will compile because it found that method. It found that Boolean method. And it's done. So I'm just going to run that tester and see what happens. See how close I'm getting here. And remember, I've got this funny thing that it's doing down here. So looks like it's going through. I passed a bunch of tests here. This is pretty good. I've passed 10 out of 11 tests. That's pretty good. Now, the same order is passing it correctly identified. This is just fantastic. Everything's working great, except for this last one. I know I just kind of faked it on the last one, so I really kind of need to figure out what's happening with this last um, same coins method. And so let's take a look at that and see how to write that. I'm in great shape. I just have this last method to write, and this is probably going to be the most difficult one. So in this one, public Boolean, oh, sorry, I already did it here. Public Boolean same coins. What we're going to do is we're going to check the other purse, and we're going to see if the coins in that other purse are the same as the coins in our purse, regardless of whether or not they're in the same order. So quarter dime, nickel dime, and nickel dime, dime, quarter, those are the same coins, just in different orders. So we're going to call those same coins. Those are considered equal. It's true that those are the same coins, even if they're not in the same order. And it says that I might want to write a helper method to help in analyzing the situation. I'm not sure I'm going to do that. I think I can probably figure this out. So what are we going to do? What's our strategy for trying to figure this out? How are we going to try to solve this problem? I guess if it's just me trying to solve this, if you ask me, are those the same thing in both those purses? What I'd probably do is I'd say, well, here's a quarter, and I'll go through the other one. Oh, there's a quarter, and I'll cross it off that list. And here's a dime, and let me go through, and there's a dime, so I'll cross it off that list. And next, here's a nickel, and oh, there's a nickel, I'll cross it off, and then, oh, here's a dime, and so each time what I'm doing, I'm marching through from 0, 1, 2, 3. I'm marching through one list and crossing coins off in the other list as I find them. And of course, if I get to quarter and this turns out to be $1 or something, and I can't cross it off the list, well, then I know I don't have the same coins because I looked for this coin here and it doesn't exist down here. So it's similar in some ways to same order. It's just that I need to be able to cross items off my list here. I need to be able to remove items from that list. Except one catch, I don't really want to remove the items from that list because this is the other person's purse. And I'm kind of crossing them off is inappropriate. Maybe I'm checking them off. So I want to look at them and kind of remove them from consideration later on. But I don't actually want to take them out of that person's purse. I want to make sure that they still stay in there. I'm just checking to see if these are the same. It's not that transfer method. So let's see if we can try and figure out how to do some of that. So, well, I said it was similar to the same order. Let me steal some of the stuff. I'm going to steal this same idea right here. If they don't have the same number of coins, then I don't even need to bother checking to see if they're the same coins because clearly they don't have the same number of coins. So I'm going to put that in there first. If my coins and their coins aren't the same in number, we can return false right away. Otherwise, let's go through that process of go through their coins and check them off against our coins. And to do that, I'm going to copy their list. I'm going to make a copy of their purse, another array list, and I will remove things from that copy of the array list. And that way it won't mess up their array list. So yeah, let's try this and see what happens. Now, to be perfectly fair, we can manipulate their array list to some extent, but I'm going to make a copy just to be super legit here. So let's do an array list called, it's got strings representing coins, and I'm going to call it other copy. And that's going to be a new array list of string values. Expand this out a little bit. And I'm going to go through all of theirs. And you know what I'm going to do? I think I'll just add them in there. I think I'm just going to say, how about this? I'll use an enhanced for loop this, and I'll say, for the string coin in other dot coins, for each coin in their coins, I'm going to other copy dot add that coin. That's going to make a copy of theirs. And other copy, that's going to be the one that I'm crossing off. So I'm not going to be messing up their other purse right there. Well, now what do I do? Now I have to set up that loop that's going to go through and try and check things off. So let's go through my list, and we are going to go through every coin. Yeah. I'm thinking about whether or not I want to use an indexed loop here. I think I probably will use an indexed loop just because it's a little more familiar to us right now, maybe. So I'm going to keep on going as long as I've got coins in mine. Coins, do this dot coins to be careful. What is up with my typing these days? Go through that. I'm out of control. And so this is going to get me a coin. And what I want to do is I want to find out if this coin, if the I coin, is in their list, in their other copy. So I think I'm going to have to set up another loop here, maybe a J loop that's going to go through other coins dot size. So I'm going to go through and I'm going to look for that in J++. And I'm just looking for something that matches that. And I think what I'll do is I'll say if the coin that I'm trying to find, which is my coin, coins.getI, it's that one here, that's the main one that we're looking for. If that dot equals, because we're comparing the strings, other coins dot get j, one loop to go through mine and one loop to go through theirs. And if I find one that's a match, I'm going to remove it. So I guess that's coins dot get j, right? Or coins dot remove j. I'm going to remove the item at that list, crossing it off their list of coins. And I think I'm going to break out of the loop. And we'll go down here. And I've got an interesting little challenge here. Let's think about what's happening here. So I'm going to make up some values here. So let's say I've got a penny, quarter, penny, nickel, and down here is a quarter, nickel, penny, dime. So I'm going to be using an I loop to go through mine and a J loop to go through theirs. So I'll start out here at 0, and I'm looking, here's my outer loop, so I'm looking at this dot coins, this guy right here, coins.getI, and I'm checking to see if any of these others in the J loop, the other dot coins.getJ, this is a J loop, do any of these values match? Does the Q match that? If not, keep on going. Does the N match that? If not, keep on going. The P matches that because coins.getI, that equals coins.getJ, this. We're going to remove J. We're going to knock that off the list. And then since I've matched that one now, I'm going to break out of that J loop. And I'll come back up here and start on the next one. So this is a shorter list now. And I've crossed this one off. It's out of contention. It's still there. I haven't removed it. I'm just not looking at it anymore. Now I goes to 1, and now I'm going to start looking for the quarters. So I'm going to go through, I'm going to get this, that I is now 1. My J loop starts over again. Check for the quarter. There it is. There it is. So I'm going to remove it, break out, and come back up. This is going to go to 2 now. Remember, I've gotten rid of both of those. So now the J loop is going to go, is N a match? No. Is D a match? Sorry, P. I'm looking at P here. Is N a match for P? No, it's not. Is D a match for P? It is not. So I'm going to have gone through this very short loop now and never removed anything and never broken out. And then I'm going to fall out down here without having crossed anything off the list. And what do I do about that? I need to recognize the fact that I went through that whole loop and never crossed anything off the list. And I don't have a way of keeping track of that right now. So I think what I'm going to do here is one of the things you can do is you can set up a Boolean variable. You can set up a flag, something that's going to indicate whether or not something happened, a certain thing happened. In this particular case, I think I want to find out, did I find something on the list and cross it off? So how about if we do something like this? We've done something similar to this in the past, a very standard little trick here. So after we've copied everything over, how about if I do this? How about every time at the top, as I begin going through and looking for the other items, I'm going to set a Boolean variable called found, and I'm going to set it equal to false. I'm going to assume I don't find a match. And then remember, so this is me going through my top list. This is me going through the other purse. And if I find it, if those two strings are equal, then what I'm going to do is I'm going to say found equals true in here. I found it, I'm going to remove it, and I'm going to break out. And then down here at the bottom, I can double check and see what happened with found. And if I found it, awesome, that's great, then I'm not really going to do anything. But if I didn't find it, if I didn't find a coin to cross off, if not found, then what I need to do is I need to return false. I need to say, I went through and tried to find another coin to match this one, and I couldn't find it. So therefore, I'm going to say it's false that we have the same coins in these two purses. So I'm going to check that flag, and if I ever get to the point where I go through the list and I don't, you know what I need to do? I actually need to do this outside of the loop here. Sorry, I did this a little bit too soon. It needs to actually go right here. After we've broken out of the loop, we'll check those things there. And if it's ever the case that we get through and we haven't returned false, if we ever go all the way through our I loop and we get down here and we haven't returned false at this point, well, that means we've gone through all the purses and haven't ever not found a match. And what that means is we are in good shape. It means that the coin's all matched and we should be all good to go. So I think that's probably going to work for our strategy in the finding the coins in the same coins, not necessarily in order. If I compile this and run this, I hope that I will be able to pass all the tests. And it looks like I passed 11 out of 11 tests. It correctly identified everything. So it's a little bit of work there. I'm going to mention one more time here as we close out on this recording that this is a super powerful little program for demonstrating how you can manipulate arrays, how you can compare arrays, classic little algorithms that we're using here to run through and check off arrays against each other. So this is a very important example, and you should make sure that you understand how it works.